What's up guys, how you all doing? Today I'm going to show you what a capacitor is, its usage, and whatever is connected to capacitors. Now this will be my first video on explaining about, well, electronic components. I'll add it to my playlist. Now I'm hoping that you're going to enjoy the video, and don't forget to share, subscribe, and or write any comments you like. Now before watching this video, don't forget to subscribe, like, and write any comments on your mind. So let's get started. Two metal sheets or metal, well, anything flat metal, two metals brought together face to face or in parallel, but they're separated. Oh, which means when two sheets brought like this, but not in full contact, just brought very close. Now, when we connect this to a battery or to any voltage source, we know when we connect it, the positive charge here starts to accumulate on the other side. Here, positive charge starts to accumulate slowly. The charge starts to accumulate here, and this generates an electric field. And that electric field can cause the other charge to move right here. It will eventually come to completion. The charge will reach its limit. That's why using a graph, this is a graph for voltage we applied. As time passes, the voltage slowly charges up and reaches the maximum point. We call it VC, or voltage through capacitance. Now, as we fully charge this thing, let's say this capacitor is fully charged. Now, if we remove this battery and replace it with an LED, start to light. But the problem with capacitors is, as quickly as they charge, they quickly dissipate all the energy at very exponential rate. So which means as time passes, the voltage running through this current or this line will dramatically drop, which means the LED, once it's reached the maximum brightness, and then slowly dims, and finally it's no more. And by the way, the graph of charging is opposite to the discharging, so we can draw it like this. It's the same right here. This is for charging, this is for discharging. So we have a formula, but it doesn't matter for the time being. So this is what it looks like. This is in short what capacitor is. We're using schematics. Now let's see this in practice, or let me show you in demonstration. Now this, if you can see it, is an electrolytic capacitor. We'll see later the types of it. But this is a capacitor which have, if you can see it, 1000 microfarad, which is slightly bigger than most average capacitors. Now we're gonna charge this, and then we're gonna see what I mean. As you can see it here, it says on the edge 1000 microfarad. It's a unit or measurement of a capacitance. It's a measure of capacitance. It says 100 microfarad, which is slightly, well, bigger than most average capacitors. Now let us charge it using a 5-volt battery right here. We're gonna connect it correctly. Here we connect it negative to negative, positive to positive. Usually, most of the time, capacitors usually take less than a second to fully charge. Let's show you what I mean by dissipation of power. You can see it right here. Now let's connect it. See that? Yeah, it's now, as you can see it. First it was very bright, and now it's starting to dim. Yeah, now it got smaller and smaller. You can see it right here. It's connected. It's still on, but a very small voltage is crossing now because of resistance. Resistance is the main cause of this dissipation of power. Yeah, it's gonna keep doing it like this. Now I think it's finally off. Yeah, see? It's starting to dim. It slowly dims away. We're gonna wait till it dims. Yep, it's still on. Now off, on. This is due to, again, resistor. There's a always parasitic resistance inside and all loads. So now it's almost gone. Yeah. Okay, now having said this small explanation about capacitors, now let me show you the types. These four are the most used or common types of capacitors, and also, well, representatives that I have at my disposal. These four have each different names. The first one, this small capacitor, you can see it right here. This is called a ceramic disc capacitor. Flat, you may find it on motors. Now this, the second one, is called a ceramic capacitor. Right here. Right here, there's a label of voltage right here, 100 volts. So which means above 100 volts, if there is a significant amount of current, this thing might explode or it may not work. Now the third one, I already show you, this is called an electrolytic capacitor. Right here you can see the writings and the rated voltage. Right here you can see 25 volts is rated. 25 volt and 1000 microfarad. And the last one, this is called a film capacitor. This is used in different applications, mostly in AC powers. This is used in AC powers. Right here above, you can see it says 0.22 microfarad and a voltage rating of 250 to 157. Yeah, I think it's clear. As you already know, capacitors can hold charge for a momentary amount of time and discharge very quickly, which acts as an, well, explosive battery. If a capacitor is fully charged and if it is charged with dangerous amount of voltage, it could be fatal. Let me demonstrate. Now this is the high voltage that I made a while back. You can see the arcs, beautiful arcs being generated. You can see it. And then I have this capacitor that I salvaged from a tailing or, and then charge this capacitor. If you can see it, guys. I am charging it. See? Okay, guys, imagine this with me. Let's just say we are working on a broken motor or any kind of device that have this capacitor mounted to it. But before we proceed our, well, investigation, we forgot to turn off or to disconnect the power source. Now, we've seen that the capacitor can be fully charged. Now, if it is charged and if it is charged with dangerous amount of voltage, the charge that is stored in a capacitor will be at the same as dangerous as a voltage we give as an input. Now, let's just say we are working and we accidentally touch this capacitor while it's being live. This is what will happen inside our body. Power. When touching it, then accidentally, then it's over. So don't forget to discharge capacitors. Okay, guys. Well, this is all for today. I've shown you what capacitor is and how it works. Don't forget to again to share and subscribe and write any comments you are thinking of. Well, this was it for today. See you next time.